Okay, so in our first question here, we need to work out the half-life using the graph. We can see that our start point is at 100. So one half-life would take us down to 50. So we draw a line horizontally across from 50 to where it meets the line. And then we continue drawing that line vertically down. And we can see that it meets our x-axis at 4 days. So the half-life of the following isotope is 4 days. Have a look at the second question. Again, we can see it's the similar shape graph. It starts off this time though at 800. So half of 800 would be 400. Going on from where it joins. And again, we go vertically down. And we can see that it joins halfway between 2 and 4, which would be 3. Checking our axis, we can see that this would now be 3 hours. In our next example, we need to calculate the net decline expressed as a ratio for the given number of half-lives. Let's take an example, and let's say we were working with something that had a radioactivity at the start of 80. After one half-life, it would have gone down to 40, because it's halving. After a second half-life, it would have gone down to 20, and again, it's halved again. If we want to think about what's going on from 80 to 20 over that time, you can see that it's actually quartered, because it's halved twice. We take one more example, we go down to 10. After a third half-life, again, it's halving. If we take that example going from 80 down to 10, you can see that it's gone from an eighth. What we can see here is that every time we go down 2, 4, 8, we're increasing by a power of 2. So we can think of it of one half-life as being 1 as a half, 2 half-lives being a quarter, and our third half-life as being an 8. And if we wanted to come up with a general way of thinking about this, we could think about it being like this, that the amount left is a half, where that 2 is to the power of the number of half-lives. So if I call it an x. 1 over 2 to the 1 will give us a half. 1 over 2 squared will give us a quarter. And 1 over 2 cubed will give us an eighth. It's a little bit quicker when we're trying to think about these answers of how we can work it out. Now additionally, it asks us to calculate it as a net decline expressed as a ratio. So for that example, if we're doing the first one here, it would be 1 to a half, which is 0.5. If we're doing this one, which is a quarter, it would be 1 to a quarter, which is 0.25. And for our third one, it would be 1 to 0.125. Okay, so let's have a look at the ones over here. So our first one, the number of half-lives is 1. We've already worked this one out previously. 1 would be a half, which would be 1 to 0.5. Now for the second one, it's to a 6. A little bit more tricky because we haven't got 1 to the 6 over here, but we can use what we're using over here. So we know that it would be 1 over 2 to the number of half-lives, which is 6. 1 over 2 to the 6 is the same over 1 over 64. So bringing that over here, 1 over 64 will be the same as 1 to 0.015625. 1 over 3, well, we've already got it over here, which would be 1 over 0.125. And 1 to the 4, again, we can work out in a similar way, is 1 over 2 to the 4. 1 over 2 to the 4 is 1 over 16th. And 1/16 is 0.0625. Okay, if you're feeling confident at doing those, and you could feel confident about doing the first two, then you can tick off here. And if you're feeling confident on the ratios, you can tick off over there. Well done.